Okay, right, a bit of second year integration. So this video is all about integrating things that look like that. Or perhaps it's written like that instead. So I mean stuff like this, right? This one here, or this one here, or maybe this one here. Okay, that doesn't quite look like this, but hopefully you know that you can do partial fractions so that you can split this up into two different fractions that look kind of like these ones. If you want to know a shortcut way of dealing with anything that looks like this, I'd start by bringing the a on the outside. You copy the a again. Now leave a bit of space here and write ln, modular signs, and then whatever this denominator there is with the 1 on the top. So ax plus b, and then you divide by the derivative of this thing here, right, which would be a, so 1 over a. And obviously, because you have no limits here, I should really put a plus c there. And so that's your final answer. Now, you don't have to learn this formula. I wouldn't recommend like learning this formula, right? But as long as you follow that process for something like that or something like that, you can't go wrong, okay? Right, so let's do this second one, right? So let's bring the -3 on the outside. So take the -3 out to the side here. Write down your ln's and the modular signs with the -3 on the outside. Copy that denominator inside the modular sign. And then you divide by the derivative of this linear function here. So -4 plus c, of course. And so that's your answer there. Sorry, that should be a modulus sign there. You may be wondering why I am using modulus signs. It's just because if you do have limits on the integration, you're not allowed to have negative values inside a log. Okay, so go on your calculator, do ln -2, you'll get an error, right? So the modulus signs just stop that from happening. Now, this process is just a shortcut. You can do this in your exams, but if you want a more professional way of doing these integrals, really what you should do is let u be equal to this denominator, do integration by substitution, and that's your more professional method of doing that. But you don't have to with these ones. You can just follow this kind of cheat code. And you may be wondering why integrating something like this gives us an ln. Well, that's because when you differentiate ln of a function, right, using the chain rule, you'll just get the derivative of this function times by 1 over this function inside the ln, just using the chain rule, okay? Literally, this is reverse chain rule. So you should now be fine with examples like this here, or this here, or maybe this here, where you do have to do partial fractions first, and then you'll get two examples like this added together to integrate. But what about an example like this? Well, if you do get something like this, try and factorize this on the bottom. And again, with this one, we actually can factorize this, so we get something very similar to this one here. Again, you do partial fraction. And what about something like this one instead, where you actually can't really factorize that thing on the bottom? Well, actually, that would not be in an A-level maths exam. That could be in a further maths exam. So what you would do is you'd complete the square, and you could use perhaps a trig or a hyperbolic identity to substitute into that and do a trig integration substitution. That would be second year further maths, not A-level maths. So you don't need to worry about things like that.